If you've already done so, before watching this video we suggest that you watch the video on how to calculate the area of squares and rectangles, how to calculate the area of rhombuses and rhomboids, and how to calculate the area of triangles. This video is based on an actual question from a state math exam. It's possible that you will also have a question like this one on your 5th grade state math exam. A teacher draws a triangle with an area of t square feet. The teacher then draws a parallelogram that has the same base and height as the triangle. What is the area of the parallelogram? When we get to middle school, we'll learn how to compare shapes without numbers. But in elementary school, it's easiest to compare shapes that have numbers. Here's our strategy for solving this problem. First, we'll estimate the values for the triangle's base and height. Second, we'll draw a parallelogram with the same values for its base and height as the triangle. Third, we'll calculate the areas of the triangle and parallelogram. And fourth, we'll compare the calculated areas of the triangle and the parallelogram. Let's start by estimating values for the triangle's base and height. We'll put this piece of paper under the base. We'll pretend this is a giant ruler that's 12 feet long. Here's where the 12 would be, here's where the 0 goes. Then we'll find the middle and write a 6 there. Then we'll find a middle place between the 0 and the 6 and write a 3 there, and then write in the numbers 1, 2, 4, and 5. Next, we'll hold this ruler so that it's vertical and measure the height of the triangle. We have 5 feet. So, for our calculations, we'll say the base is 12 feet and the height is 5 feet. Next, we'll draw a parallelogram with the same values for its base and height as the triangle. As a reminder, all of these shapes are parallelograms. But since we want a parallelogram that has different values for its height and base, that means we can't use a square. A very common parallelogram we use a lot is a simple rectangle. So we'll choose a rectangle for this question. We'll refer to this rectangle as a parallelogram or a rectangle for the rest of this problem. As with the triangle, we'll make this rectangle's base 12 feet and its height 5 feet. Next, we'll calculate the areas of the triangle and the parallelogram. To calculate the area of a triangle, we do 3 steps. Step 1. Write out the formula. Area equals the base times the height divided by 2. Step 2. Substitute the words with numbers. In this case, the base is 12 feet and the height is 5 feet. Step 3. Calculate. We'll do this in 2 parts. Part A is to multiply. 12 times 5 equals 60. Part B is to divide. 60 divided by 2 equals 30. So the area of this triangle is 30 square feet. To calculate the area of a square or rectangle, we do 3 steps. Step 1. Write out the formula. Area equals the base times the height. Step 2. Substitute the words with numbers. In this case, the base is 12 and the height is 5. Step 3. Do the calculation. 12 times 5 equals 60. So the area of the rectangle is 60 square feet. Next, let's compare the calculated areas of the triangle and the parallelogram. Here's a summary of what we've done so far. The triangle's area is 30 square feet. The parallelogram's area is 60 square feet. We could compare these areas by calculating their difference. 60 minus 30 equals 30. So the parallelogram's area is 30 square feet greater than the triangle's area. Another way we could compare their areas is to calculate their quotient. The parallelogram's area is 2 times more than the triangle's area. Now we're ready to return to the answer choices. The question states that the capital T stands for the area of the triangle in square feet. In all of these answer choices, we see a number next to the capital letter T. Whenever a number is alongside a letter, that means the number and letter are being multiplied. Since the answer choices involve multiplication, we'll choose our comparison phrase that involved multiplication. We need to convert this phrase into an expression that is part of an equation, just like the answer choice formats. We'll replace the word triangle with a capital letter T. We'll replace the word is with the equal sign. We'll replace the phrase times more than by putting a number 2 next to the letter T. We'll add the units of square feet. Option C is correct, because the right side of the equal sign is the same as option C. Here's one way to think of how the question and the answers are arranged. If the question was, how tall is Pat? Then the answers could be any of these. Pat's height is 6 feet. Pat's height equals 6 feet. 6 feet. In the last case, the answer just shows the part on the right of the equal sign. That's the same format that the test makers use for this question. Thanks for your attention.